everyone. Yes, still good morning. We are going to work on some skill building at the beginning, and then hopefully we'll get to using Jacobians to find integrals by changing the variable. So you read that out loud as partial dxy by duv. So partial dxy by duv. If you stick two lines around it, it's a positive numerical value of that guy. For some reason better known to themselves, my WebAssign is only getting you to do this fella, which is a bit annoying because when you do the integral, you should be using that guy. But having said that, take this guy and basically to find what's called the Jacobian. So that's the Jacobian, and this is the positive value of the Jacobian. You take the partial derivative of x with respect to u, partial derivative of, keep getting these guys mixed up, x with respect to v, then y with respect to u and y with respect to v. And let's look at the first thing, which is how do you, let's just practice that out. Yes. Question? Okay.
No, I just swallowed my coffee wrong and then I coughed and didn't realize it wasn't muted.
Okay. So we have 5. So x is 5p e to the q, and y is going to be 2q e to the p. So there's some kind of symmetry going on there. And we're being asked to find the Jacobian, which is, in this case, the variables are called p and q. So you differentiate x with respect to p, and then x with respect to q, then y with respect to p, and then y with respect to q. Oops, should be a little baby q. And those vertical lines don't mean absolute value, they mean discriminant or determinant, I should say, of this guy. So let's see what we get. If you differentiate this with respect to p, you get e to the 5q. If you differentiate this with respect to q, you get 5p e to the q. If you differentiate this with respect to p, you get 2q e to the p. And if you differentiate this with respect to the q, you get 2e to the p. How does that look? It looks fine. So major diagonal is 5e to the q times 2e to the p. Take away minor diagonal, which is going to get me 10 pq e to the p e to the q. Okay, that's going to get me 10, so I'll pull that out as a common factor. These two get me the same as that, so e to the p, e to the q. Something's looking, yeah, that's okay. I was kind of confused. 1 take away pq, agreed? Just tidying up. So I'm pulling out an e to the p and e to q, and I'm pulling out a 10 as a common factor. That's all used up, and there's a pq left here. And now I've just noticed it. Slight improvement. It looks better if you combine the two e's together. And so we have finished finding the Jacobian. And that fella is a major part of what you need to know to do a change of variable. So you'll need to find this guy every time you do a change of variable. Are we comfortable about the algebra? Differentiate x with p and q, differentiate y with p and q, major, take away minor, and you got this guy. I think yesterday I did the polar version just to show you where that came from. Oh, not that you need it for this question, but remember your dv, which is your dx dy guy. He becomes the Jacobian with an absolute value around it, dp dq. So in this, keep on doing capitals there. So in this case, you would have a 10 e to the p plus q, 1 minus pq dp dq. So that's what your dx dy would turn into this. And all you would need to do to finish the question would be to find out what the new limits of integration are. But instead of in terms of what x's and y's are, you have to find the limits of integration according to, in this case, the p's and the q's. So far, so good. And that's our first one. So say it's a skill building exercise. I called that question 1. My apologies, it's actually question 3. Let's do a question 1 then. In this case, x is 4u plus v, and y is 5u take away v. And we're going to do the Jacobian in terms of u and v this time. So you differentiate x with respect to u and v, and then you differentiate y with respect to u and v. These are going to be numbers, I think. If you do this with respect to u, you get 4. And if you do it with respect to v, you get 1. If you do this with respect to u, you get 5. And this with respect to v, you get 1. And the major diagonal, take away the minor diagonal, gets you the number -9. And that's what WebAssign is expecting from you. And I wish they hadn't, because really, that's the guy that you really want. So there'll be 9. So are you comfortable that there's like 2 flavors of this, one without the sign being changed and one with? You might think, well, what does this become? Technically speaking, shouldn't I stick an absolute value either side of that? In a lot of cases, we just assume that it's positive, so we don't need to. So this answer is the one that WebAssign wants. But this is what you're going to have to use when you integrate. So bear in mind that little hiccup. What will it cause? Won't your answer be positive when it should be negative, or negative when it should be positive if you didn't do this conversion? In other words, the only bad thing it will do is it'll make your sign of your answer wrong, right? Instead of plus it's minus or vice versa. Now, I want to see if I can get away with one more. No, okay. I'm going to show you one example, really only for completeness sake. Of a Jacobian for a triple integral. We're not going to do triple integrals, but if you were going to do one, you would need 3 variables, right? In this case, u, v, and w. And the Jacobian is x, y, z with respect to u, v, and w. That seems reasonable. But you end up with a 3 by 3 matrix. So you differentiate with respect x with respect to u, v, and w. You do y with respect to u, v, and w. And you do the partial derivative of z with respect to u, v, and w, right? Now, the ones we are really going to be dealing with when we do integrals are the 2 by 2 guys, right? And they're easy to do. Major diagonal, take away minor, right? When you've got a 3 by 3, the formula is much more ugly than that. But let's put in some values first before I start talking about the formula. If you differentiate this guy with respect to u, you get 5v. With respect to v, you get 5u. And with respect to w, you get 0. If you take on the middle one, with respect to u, you get nothing. With respect to v, you get 2w. And did I get that? And with respect to w, you get 2v. Yeah. And the last one, if you do it with respect to u, you get 8w. With respect to V, you don't get anything. And with respect to W, you get 8U. Does that look good? Okay. Now, to calculate the determinant of this 3 by 3 matrix, you take the first guy, this guy, and you do the major, take away the minor. So in this case, it's going to be 2W times 8U. So that's the major, take away nothing. And then you subtract the middle guy, in this case, 5U. And you kind of cover that up. And the 2 by 2 that's missing, right? The guy that's a little 2 by 2 there. Major is nothing, take away that guy. So you're going to get nothing, take away 2V times 8W. And then you finish with plus this guy. Well, since this is 0, I don't care what the rest is, but if you want to know what you would do, it would be major diagonal, take away minor diagonal. So this is 16 and 5 is 80 UVW. And this one is 2 negatives make it a plus. 5, 2, 8, 6, 10, 80 again. Oh, UVW. And so it adds up to being 160 UVW. So if you had to do a Jacobian in 3 variables, this is the formula for it. Once you've got the terms, it's first guy times that determinant, middle guy times this determinant, last guy times this one. And remember to do the little minus in the middle. If you've done linear algebra, you should say, yeah, I remember that formula. Right? And it's the same formula. Are we cool with finding Jacobians of 2 by 2? Because that's the only ones you really need to worry about. These guys. Are we comfortable? Can I move on? Do you want to say another one? We're good. Okay.
So is number 4 in the homework 3 by 3 matrix or?
Yeah, it is.
Oh, yeah.
It's this one. Well, it's this one with my numbers. I think in your case, the 5, the 2, and the 8 will turn into something else. But apart from that, the process will be the same.
Gotcha.
So we've done the first part of the job. How do you find Jacobians? Second part of the job is finding double integrals using change of variable. So it's kind of like you would do in Calc 2, where you would use a change of variable, but your change of variable would be u equals x squared plus 1, right? That's a single variable change of variable. We're going to do a double change of variable. So let me find one to start the ball rolling. Here we go. Okay. In this, oh darn it, I've moved to the wrong page. Never mind, I'll get back there right now. So this is a version of question 5. And we're being asked to find the double integral over some region R of x take away 6y. And for some reason, well, not for some reason, they're calling it dx. The change in variable is that x is going to equal 5u plus v, and y is going to equal u plus 5v. So far, so good. Right? Now, there's going to be a problem. Well, let's just do what we need to do and then we'll figure it out. First thing we're going to do is we're going to find the Jacobian. We know that's part of the process, so we might as well find it here. You could find it later on if you wanted, but it needs to be found. Differentiate the x with respect to the x with respect to u and v, and then differentiate the y with respect to u and v. And this is going to be with respect to u, you get 5, and with respect to v, you get 1. With respect to u, you get 1, and with respect to y, v, you get 5. And that gets you 25 take away 1 is 24. And since that is positive, I'm really happy. Agreed? I don't need to worry about changing anything. That's pretty mechanical, right? You've got a formula, you know what to do, you get an answer. Don't expect this to be a number all the time. It was only because these particular change of variables were very simple. But you know, if it's u squared plus v squared kind of thing, won't they turn into some function of u and v, right? So if you're doing it correctly, this will have u's and v's in it. Now, step 2 is the bit that's going to cause the trouble. We have to change, well, not change, we have to find, that's a better word, the limits of integration. In terms of u and v. That's the killer. That's the guy that causes the trouble. Normally the Jacobian is not the problem. The problem is getting u equals 1 to u equals 7 and v equals 2 if v equals 10, right? The limits of integration, right? And in later questions, you're going to have u equals v squared to u equals v squared plus 2 and u equals 1 to u equals 3, right? You're going to get a change, a limits of integration of u's and v's. Now, what I haven't told you yet, so I'm going to write it down here, is that the region that we're going to be integrating is over a triangle that uses these 3 coordinates. So there's 0, 0. Here is 5, 1. And here is 1, 5. Are you comfortable? Doesn't need to be a scale, but are you comfortable that is I? Right. We might as well write it down here. We know that x is 5u plus v and that y equals u plus 5v. So far, so good. Okay, now what I'm going to do is I'm going to, I guess I should put colors on them. I am going to take each side of this triangle, because a lot of your questions are triangles. That's this green side here. And I am going to find its equation in terms of x and y. Are you okay with this green guy being y equals 1/5 x? Would you agree that green line, don't know how green it looks to you, but isn't that a slope of 1/5 passing through the origin, right? This guy is going to help generate the limits of integration. If you replace the y with u plus 5v, and you replace the x with 5u plus v, and then you do some algebra on it, so far so good. If you remove a u from both sides, you get that. If you subtract 1/5, I know it's weird, but if you subtract 1/5 v from both sides, you get that. You still with me? What does that tell you? What's v equal to? And don't overthink it. Hey, we have found one of the limits of integration. Doesn't v go from 0 to someplace, right? Don't know what that someplace is, but hopefully, you know, that'll come out in the watch. Now let's take this point here, which is 5, 1, and this point up here, which is 1, 5, and I'll make it a very thick black one. I am now going to find the equation of that line and plug in the x with this guy and the y with that guy, and with a bit of luck, right, I should be able to get some other piece of information using limits of u or v. If you take this guy, God, that's going to be hard. If you take the point 1, 5 and the point 5, 1, and then what you got? You got 4 by, oh, it's not as bad as I thought. Isn't it y equals negative x? So far, so good. Now, if you do, the slope is -1, and you use this formula, point slope equation, and maybe use this guy, although I could use that, it would be the same answer. I get y take away 5 is -1, x take away 1. And I get y take away 5 is -x plus 1. So I get y equals -x plus 6. Are we okay about how I found the whole kit and caboodle, right? Now move over here and take the equation and replace this with the x and replace this with the y. And what do I get? I get a u plus 5v is -5u plus v add 6. So far, so good. Now, I better put circles around them. I already know that v is this number. So let's see what this gives me. I have a u plus 5v is -5u take away v add 6. If I add a v to both sides and I take away a u from both sides, I believe you get that. Are we cool? And now I'm going to get v equals -u plus 1. Are you happy about that? Well, guess what? I now have the limits of integration for v. Doesn't v go from 0? And I don't like the way that's written, so I'm going to call it 1 minus u. Hey, we're halfway there. Don't we now have the limits of integration for v? And it has to be in terms of u, right, or numbers. Now, there's one guy left in this kind of puzzle, and we got this guy going this way. And this guy going this way is a straight line y equals 5x. I'm going to replace this guy and 5 times this guy. And distribute the 5. And so can I just say u equals 0? It saves me writing a whole lot of stuff. Would you agree u equals 0? Now, that's good, because I know one of these is 0. It's probably going to be this one, but I don't know this guy. And doesn't it have to be a number? When you do a double integral, if one of them's a variable, doesn't the other one have to have 2 numbers in it? So I know it's going to be a number. And what I'm going to do is I'm going to draw a UV axis. And what do I have? I have V equals 1 minus U. Would you agree that V equals 1 minus U is a straight line? In fact, what is the other guy? Well, if you put V equals 0 in it, aren't you basically talking about that triangle? And doesn't that make U 0 and 1? So do you see how I had to find the last one by kind of sketching the information in the first one and then trying to figure out what it told me in the other one. But we're done as far as step 2 goes. And so the first stage, whatever I put the damn thing, the first stage was find the Jacobian, which we did. Now I can't find it. Is it under here? Oh, there we go. Find the Jacobian. Step 2 is to find the limits of integration, which thankfully we now have. And so the last piece of the puzzle is to take the original integral that we're being asked to do, right, this guy here, I'll call it dx dy, and it's now going to become v equals 0 to v equals 1 minus u equals 0 to u equals 1, right? That's what the limits of integration are telling us. The x is going to become 5u add v. Take away 6y, which is going to be 6u plus 5v, times the Jacobian, dv du. So I have u equals 0 to 1, v equals 0 to 1 minus u. What's that going to be? 5u, take away 6u is negative u. 1v, take away 30 is going to be negative 29v. The Jacobian was, I've got to have tons. What was the Jacobian again?
24.
24, thank you. So 24. Why am I doing dv du and not du dv? Because I could have it the other way around, couldn't I? But that wouldn't be a good idea in this question.
Because v, the limits for v are what have the equation.
I agree. Now, in this question here, don't let the u's and v's bug you. Isn't this basically just a normal double integral? Agreed? And since this question has taken a lot of time, can I dot that and you could finish it in your own time? So taking this particular double integral over the region R ends up becoming this new double integral. And this answer is the same as that one. And evidently the answer to this question, because I can see it here, is negative 120. Okay, you've only seen one, so it's hard to say, does that make sense to you? But hopefully, if we do a couple more, depends on which time we've got, it'll make more sense to you. So which one shall I pick this time? The one that I've done, which was question 5, question 6 is virtually the same question, right? So if you look at 5 and 6, you're doing the same thing. Let's move on to 7, do I want, or 8? I'm going to do 2, I guess I need to do. Doesn't really matter. I'll do 7. And in this time, it's a double integral of 4x add 16y dA. The region R is going to be a parallelogram using these 4 points. And the substitution is going to be x is 1/4 u add v, and that the y is going to be 1/4 v take away 3u. So I'm going to go through my hit list, and my hit list is find the Jacobian, find the limits of integration using u's and v's, and then finally set up the integral. So I guess I should put that here. Well, in this case, the Jacobian with respect to the two variables u and v differentiate x with respect to u and with v, differentiate y with respect to u and v. Can you kind of see why we don't do 3x3s? Why the math involved in doing a change in variable with a triple integral could in many cases just be horrendously difficult, right? Just so much going on. 2x2s are bad enough, right? But can you imagine 3x3s? Not very obvious. But hopefully this will come out good. Me personally, I don't like the way it's written. I would rewrite it like that. It's just going to make my life easier. And I would rewrite this guy like that. Okay, so if you differentiate this guy with respect to u, you get a quarter. If you do it with respect to v, you also get a quarter. If you do this guy with respect to u, you get -3/4. And with respect to v, you get +1/4. The major diagonal is a quarter times a quarter. Subtract the minor diagonal, which is this guy. You get 1/16 plus 3/16, and the Jacobian is a nice positive number. So I don't need to worry about changing any signs of things. It's a quarter. That's probably going to be the easiest part of this process. Would you agree Jacobians are getting kind of easy, at least if the functions aren't weird. Pretty easy to do. Now, we are given the coordinates of x and y, and they are -1, 3, so that's there. 1, -3, here. 3, -1, which is here. And lastly, 1, 5, which is here. And we're told it's a parallelogram. Yeah, looks a bit like a rectangle on its side, but that's a parallelogram, right? We now have to take this region, this red triangle, and figure out what the limits of integration are in terms of u and v. So I'm going to have to call these letters. I'm going to call this guy A, B, C, and D. So what I'm going to do is I'm going to find the equation of AB, BC, CD, and AD, right? I'm going to find those equations. I'm going to substitute the X with this guy and the Y with that guy. And with a bit of luck, we should be able to find the limits of integration in terms of U and V. And one of those two, I don't care if it's the U or the V, shouldn't it be a number to a number, like 0 to 1 or 5 to 7? So any particular order you want me to do these guys? Pick one and I'll start it.
AB.
Okay. If you want to get AB, when you look at this one, how many is that? That's 3 by, is that 3 by 2? Let me check. 1, 2. Oh, okay, 2 by 2. Oh, it slopes 1. And I believe it's x add 4. Can you trust me it's x add 4? Right, I'm going to cheat for the others. And I'm just going to write what the equations are. And I believe I've got these in front of me. So what do I get? If I call that one, this one down here, shouldn't it? That's DC. Shouldn't it also be the same as that one? So it should be X, but I think it's going to be X minus 4. Check that. Yeah, it seems reasonable. X minus 4. What about BC then? What's that going to be? 5, 6 by 2, so it's going to be 3x Did I have a 3x? Equals 3x. I can't find it. Should be here. Oh, it's negative 3x because it's pointing down the way. Okay, we have a negative 3x. That one, negative 3x. And this is going to be a negative 3x plus something. Negative 3x plus 8. Right. You can check that. I'm just using answers and looking at a picture. These are the 4 straight lines. Okay. Now each one of them is going to get replaced with these guys, and hopefully that will generate some information. So there's the first one. Now if you put y in, you get 1/4 v take away 3/4 u, and it's going to be equal to x, which is 1/4 u plus 1/4 v. And what can I do with this one? Well, I actually don't.
Don't forget the +4.
Oh, thank you. Almost screwed that up. If you cancel these guys out and you subtract 1/4 u from both sides, would you agree you get that? And haven't we found one of our limits of integration? All right. Got 3 more to go. So we've done that one. That one essentially told me that u was -4. Okay. Just do it sequentially then. I'll do BC next. And we have y equals -3x add 8. Y is going to be 1/4 v take away 3/4 u, and it's -3 times 1/4 u plus 1/4 v. That gets me -3/4 u, -3/4 v. They cancel each other out. If I add 3/4 to both sides, I get v. Oh, and I almost forgot my plus 8. And I get v equals 8. Can you see where this is going? Right. For time purposes, I'm going to tell you what the other two eventually get you. When you use CD, what's CD? You are going to get, is it CD? Oh, they don't tell me which one is which. So CD is probably this one. So it's going to give me something we use in it. And CD is going to give me what? It is going to give me U equals 4. And AD is going to give me eventually V equals 0. So if we pretend that we actually did the other two, and by the way, just in case I'm wrong, maybe this gives you V equals 0 and that gives you U equals 4. But that's the guys you're going to get. Terence, had your hand up, I didn't notice.
I'm not sure why there's not an 8 in the formula for AD.
AD doesn't have an 8 in it, you're right. But AD goes through the origin. So the equation of that line is just negative. What is it? It's negative x. AD.
Okay, so the x equals the offset from the going through the origin. It just x plus 4 x.
The offset is a little distracting to me. I'm trying to think what you're getting at.
What I'm getting at is that, you know, you've got x plus 4 and x minus 4 for two of the equations. So
I may have written these down wrongly. I just wrote them down because I did them in my head. I'll have a double check in case they are wrong. So CD, let's just do it. CD is that one, is definitely a plus, and I'm looking at it as 4. So I'm happy with that one. Right, this line's up at 4, that makes sense. This line is down here at 4. The negative 3x one, I might have to do that one. That's this one here. This one here, no, I'm actually happy with those. Those all work. So what were you asking, or what do you think might be different? Or maybe you're just saying, where's the 8, I guess is what I heard.
I think he's probably wondering why AD doesn't have an 8, whereas BC has an 8.
Well,
Yeah, that's what I'm wondering.
Right, yeah, if you look at AD, do you see it goes through the origin, so it doesn't have a constant term? And do you see the BC one, doesn't it cross up there probably at 8? So this one has an 8 because its y-intercept is 8 and its slope is -3. And this one doesn't have it because it goes through the origin. So all it has is -3x. And these two, this one has a 4 and a -4 because this crosses the y-axis at 4, whereas this other one crosses the axis at -4. Okay, so we got all these limits of integration, and we also have a Jacobian. So the last stage of this process is just to set it up. And so I have the integral from v equals 0 to v equals 8, and the integral from u equals -4 to u equals +4. And the function that we're meant to be doing it to was 4x plus 16y. And the Jacobian we got, I can't find it, there's a quarter. And we're going to then have a du dv. So the only thing that I guess is left is to replace this with the u's and v's. So it's going to be 4 lots of x, so it's going to be 4 lots of this guy. Add 16 lots of this guy.
Why don't we just distribute that 1/4 through the 4x plus 16y before we do all that?
I'm going to do that right now. In which case, what do I get? I get a u plus v and a 4v minus a 12u. Oh, I could have done it that way, I guess. I'm going to have a quarter. I'll stick it out there. There's more than, one piece of algebra that does this. I'm not going to get too much out of this, but 5v, take away 11u, du, dv. There, we set up the integral. Is there anything, I'm just, what I'm like, is there anything obvious I might have been able to fix here? I don't see anything. I've just pulled that quarter outside just to get out of the way. So wouldn't that be a pretty straightforward double integral in terms of u and v? So ... You don't get an awful lot miles per gallon in these questions, don't you? You have to do a lot of work just to find one. So the only time you would ever use a change of variable would be if using x's and y's gave you an integral that's just not doable, and polar coordinates didn't help you, right? So hopefully that would be, oh, there is another way. Couldn't you change the order of integration? Because maybe the x's and y's aren't very pretty, but if you make the y's and the x's, it's a little bit prettier. That would be another get out of, how to do it. Let's see if I can find one. Right. Don't know if I've got time to finish this, but at least I've got time to start it. We want to find the double integral of this integral. And the region R is described as 16x squared plus 9y squared equals 144. You might recognize that as an ellipse. And the substitution, oh, that's nice. I like it when the substitution is really small, right? So let's get the show on the road. If I want to do the Jacobian, differentiate this with respect to u and then with v, differentiate this with respect to u and v, and we get the Jacobian as 12. right? Now this one's got a little bit different going on. The ones that we've done so far haven't been coordinates that you've been given. This is the first time that the region R is basically described as a curve, right? In this case, an ellipse. So how do I find the limits of integration this time? Well, you have to approach it a little bit differently. I'm going to take that guy. I'm going to replace the x and the y. So I now get 16 times 3u squared plus 9 times 4v squared equals 144. So that's what that ellipse in xy space would look like when you convert it into the uv space. And I don't know what that's going to be because I'm not risking it, but 9 times 16, oh, it's 144u squared plus 144v squared equals 144. And that is u squared plus v squared equals 1. So in the uv space, don't we get a circle, center 1? Now I could generate limits of integration going vertically and scanning from -1 to 1, but that's actually probably more work than it's worth. So what I'm going to do is I'm going to represent this in terms of polar. So r is going to go from 0 to 1. Theta is going to go from 0 to 2 pi. And our integral, which used to be called du dv, is now going to be called r dr d theta. Wouldn't this be the equivalent of doing a u sub and then having to do another u sub after it? You know that if you ever done a couple of questions, that's pretty rare, but if you ever done a u sub and you got a nice answer, but you still had to do another u sub to get the final answer. It's a bit like repeated chain, right? Repeating the process. So I'm good to go. I just have to make sure I don't lose track of things. So the original integral looked like this. Okay. It's going to turn into basically the circle radius 1 in terms of u and v. The 3x squared is going to become 3 times 3u squared. The dA is going to become the Jacobian, which is 12, times du dv. So it's going to be, oh, what's that? 927, that's a lot of numbers. 3 times 9 times another 12 is going to be 324 u squared du dv, but it's over a circle. And I'm taking that and I'm now going to turn it into r equals 0 to r equals 1, theta equals 0 to theta equals 2 pi. In other words, I'm doing polar on it. And the 324 is going to be called, well, u is the x's, so I'm going to call it r cos theta squared. And the du dv becomes r dr d theta. Are you comfortable with the double dip thing? I turned it into UVs and then I turned that into polar. Okay, now if I rewrite this a little bit, can't I pull out the 324 and have a cos squared theta from 0 to 2 pi? And then do an r equals 0 to r equals 1 of an r squared once an r cubed. So what I did there, because I'm running short of time and space, is didn't I separate the variables and plug out that 324? Wouldn't that be, well, that would be a quarter r to the 4. How would I deal with the cos squared? We did this once, I think it was yesterday.
That would be the 1/2 plus cosine you did over 2.
It'd be 1/2, correct? Cosine, 1/2 times cosine of 2 theta plus 1. Right, finish the brackets. Right, could do it that way, and off you go and get your answer. But do you see how that one had a different approach, because the region R wasn't described as corners of a shape, but was described eventually as a circle? Well, last name. We haven't done, I don't think I've gave you enough help yet to do all of these questions. So I'm going to keep them up, but they're not going to be due for this coming homework due on Sunday, right? But there will be an online test as always, but it won't have change of variable in it either, right? So I'll keep it open because you might want to do some questions just so that you've less to do next week. And your online test will appear sometime around about 3 o'clock today. Rosie, what you got?
So does that mean our quiz for this week is only on 15.8?